All right, I want you to check this out. Here is Malaysia. Capital city is Kuala Lumpur. Here's the city of Perth on Australia's west coast. See Australia there. British Airways Flight 9 is flying from Malaysia to Perth. And they're somewhere over Indonesia when the pilot gets on the PA system and says this. This is an exact quote. "Ladies and gentlemen, this is your captain speaking. We have a small problem. All 4 engines have stopped. We're doing our damnedest to get it under control. I trust you are not in too much distress." All 4 engines. Little problem. No worries, though, right? When Captain Eric Moody made that remarkably calm announcement to the 260 people on board his plane, the plane was 37,000 feet in the air with no engines. Captain Moody glided the plane down 24,000 feet in total silence. Remember, no engines. Finally, at 13,000 feet, he was able to get one of the engines restarted. At the last minute, he got 3 of the 4 engines restarted, and he got that plane down safely. He's the British Sully, in other words. Once that plane was on the ground, it got even weirder. There was an acrid, sulfury smoke in the cabin that no one could explain, and the windshield of the plane was completely opaque, like it was sandblasted. All the flight crew had been able to see through the whole thing was a bizarre, luminous glowing around the plane. And that incident, which happened in 1982, is why we have rules about not flying through clouds of ash from volcanoes. A volcano in Indonesia called Mount Galunggung, forgive my pronunciation, had erupted. That British Airways flight went right through the ash cloud. It was at night. They couldn't see it. Ash clouds are dry, so they don't turn up on weather radar. But the particulate matter and the silicates from that volcanic cloud just locked up that jet's engines. The rules now are that flights are supposed to keep 120 nautical miles away from any volcanic ash, which is all well and good. Volcanoes do go off from time to time. Good to have these rules. But the 7-mile-long plume of ash that has come out of this volcano that's just erupted in Iceland is so huge, and winds are spreading that ash so far that all flights in and out of Britain are canceled, at least until noon local time tomorrow, something that has never happened in living memory. Airports in Ireland, Holland, Denmark, Norway, Sweden, Finland, Belgium, France, and Germany have all canceled flights, making this the biggest disruption to air travel since 9/11 by far. This is the second time in a month that this particular volcano has erupted. And the current eruption happened under a glacier, causing floodwaters that forced hundreds of Icelanders to have to evacuate. One weird fact about this, though, even though Iceland is right in the middle of all this, the eruption is happening in Iceland, the eruption there is not affecting flights in and out of Iceland itself. You can blame prevailing northwesterly winds that are slowly blowing this ash plume all the way across Europe. Now, no one knows when the weather might shift to allow planes back in the air. No one knows how long this volcano is going to continue to erupt. I don't want to be a Debbie Downer or anything, but the last time this volcano erupted back in 1821, it kept erupting for more than a year. I'm joined now by Tina Neal. She is a volcanologist with the U.S. Geological Survey. She has studied volcanoes extensively, including flying around active volcanoes to monitor them. She joins us tonight from Anchorage. Tina Neal, thanks very much for being here. Appreciate your time.
Happy to be here.
Does the giant size of the plume of ash from this particular volcano have anything to do with the fact that it is under a glacier? Do we know what explains why the plume is so big?
Well, you are correct. The fact that this eruption occurred under an ice cap added to the explosivity of the event, and so that did produce a large volume of fine particulate material which is drifting across Europe. But I should point out that really, as eruptions go around the planet, this is not one of the largest ones. This ash cloud is not bigger than ash clouds we saw from Alaska just a couple of years ago. It's just that it's so close to a populated area with a lot of air travel that it's making such a disruption.
What is in that plume of ash that makes it so damaging to aircraft? What's in that? What looks like a cloud, but we know isn't?
Right. Volcanic ash clouds are mixtures of fragments of lava, crystal, and volcanic glass, along with volcanic gases. And they are hot when they erupt, they travel high into the atmosphere, and then are carried with the prevailing winds. But it's the solid particulate material that is most dangerous to aircraft. A jet flying through an ash cloud will suffer abrasion of the windscreen and the leading edges, as you described. But more severely, if enough ash is ingested into the engines, they can actually quit. It's the ash that's interfering with the operation of the jet engine.
In 1783, I spent a long time reading about this today, so forgive me, but as far as I understand it, poisonous ash from an eruption at a different volcano in Iceland apparently damaged crops and caused damage to such an extent that it's blamed for killing thousands of people in Europe. Again, this is back in the 1700s. Other major eruptions have been said to change the climate, at least for short periods of time. How do you know whether a volcano is going to cause long-term, regional, or even global effects? What's the most important thing to know about an eruption to know whether it could be that severe?
Well, those eruptions were quite unusual in that they were very long-lived. They went on for more than a year, and they erupted voluminous quantities of lava and ash. This eruption so far is much, much smaller, several thousand times smaller than the size of those eruptions. So the most important parameter really is the duration of the eruption and how much lava and ash are emitted.
Is there any way to predict what the duration of this eruption will be and, I guess more in practical terms, when planes might be flying again in Europe?
Well, it's not a certainty, but you can look at the past eruptions of this volcano, and that's a good guide to what they're probably going to do in the future. And the past few eruptions of this particular volcano have lasted months to a little more than a year, but they've really erupted only a very small amount of material, less than a cubic kilometer. And for comparison, the 1980 Mount St. Helens eruption was a cubic kilometer, so a tenth of that size. So I don't anticipate that this eruption will be much greater than those. However, the Icelandic volcanologists have this volcano well wired. They're monitoring it with a variety of geophysical instruments. And so if it were to intensify or grow much larger or give signs that it were going to intensify and grow much larger, they should see some signals of that.
One last question for you, just about your own experience. I know that you've flown in planes around active volcanoes to view ash and gas plumes from volcanoes when they're going off. I think we've got some footage here that you shot from the Okmok eruption in Alaska in 2008. How hard is it to monitor a volcano from the air when the ash from that volcano, as you're describing, is so damaging to aircraft?
Right. Well, you have to keep a safe distance, and really your aerial observations are giving you visual information about what's going on so you can interpret firsthand the process. But it's very important to have instruments on the ground that are detecting earthquakes, tracking the changing locations, depths, and sizes of earthquakes, instrumentation on the ground that's measuring the volcano changing shape and moving as magma is moving underground. And it's very important to use satellite technology to look down at these ash clouds from space to see how big they are and which way they're traveling. So you really need a variety of monitoring techniques in addition to aerial observations via aircraft from a safe distance.
Tina Neal, volcanologist with the U.S. Geological Survey. You have a really cool job, and it was really cool of you to join us tonight from Alaska at a real busy time. Thank you so much.
You're welcome.